Hey folks, Shubh here. So today we are back with a question which has been recently asked in the JEE Mains. In every paper of JEE, you can see that these type of questions on series is very common. So in this video, we will discuss on how to tackle these type of questions on series and progressions. So in our previous videos, if you see, we have made videos on telescoping series. We have already discussed what is a telescoping series and how to tackle like these type of series. So whenever we have a series something like this, what we do, we start it by writing the general term. For example, here the term n. For example, I'm trying to define what will be the general term over here. It will be n upon 1 minus 3 multiplied by, I think it's n squared plus n to the power 4. Now you can see that in every part of that series, like there are some constant, like for example, the 3, that's constant, right? For like the 1 is also the constant over here. But the 1 here, the 2 here, they are progressively changing, right? Similarly, using that pattern or using that series, I try to define the general term or the nth term of the series, right? So, so obviously in this question we have to find the sum of the series. So what do? We simply add the sum, like add all the terms. So what do we do to find Sn? We do the summation of Tn. So whenever we have this type of sequence, we always remember we have to express the function as a two, or like you can say that we have to express the Tn as a difference of two different functions. All right, let's start. Okay, so we have Tn as n divided by 1 minus 3n square plus n to the power 4. Now if we try to express the numerator in terms of denominator, what we can do is Tn is equal to n divided by n to the power 4 minus 3n square plus 1. Similarly, to express in the terms of denominator, we have to break the denominator as n to the power 4 minus 2n square plus 1 minus n square. The reason why I broke the denominator in this manner, you will get to know why. So here you can see that this is nothing but the expansion of n minus 1 or n square minus 1 whole square, and this is same as n square. So Tn can be expressed as n divided by n square minus 1 whole square minus n square. Now in the denominator we have an expression in the form of a square minus b square, and we all know what is a square minus b square. It is nothing but a plus b multiplied by a minus b. So we can write it as n divided by n square minus 1 plus n multiplied by n square minus 1 minus n. That's it. Now if you see a pattern here, if you subtract those two terms which is obtained in the denominator, you will get 2n, right? So what we can do here is we can multiply and divide 2 in the numerator and in the denominator. So it will be 2n divided by n square minus 1 plus n multiplied with n square minus 1 minus n. Now simply we can write that 2n as half multiplied by, we can write that 2n as n square, just a second, that will be n square minus 1 plus n minus of n square minus 1 minus n whole divided by n square minus 1 plus n multiplied by n square minus 1 minus n. So we can break that term n as half multiplied by like just separate the two terms, like the subtraction of two functions. So it will be 1 by n square minus 1 minus n minus 1 by n square minus 1 plus n. That's it. So we already discussed in the last slide that just let me take it to the next page. So Sn is basically summation of Tn, and we have Tn as a subtraction of two different functions of n. So we can write that as summation. What is Tn? It is nothing but 1 by n square minus 1 minus n and minus 1 by n square minus 1 plus n. We just use the n from 1 to 10. That's it. That will be the summation up to the 10th term. So here we just replace n as 1, then we go on replacing n as 2, n as 3 up to 10. So it will be 1 by, first n is 1, so it will be 1 minus 1 minus 1 minus 1 by, this will be same as 1 minus 1 plus 1. This is for T1, sorry. Similarly, you replace n as 2, so it will be 1 by 4 minus 1 minus 2 minus 1 by 4 minus 1 plus 2. That's the second term. So we just have to add all that. That will be 1 divided by, now the third term will be 9 minus 1 minus 3 minus 1 divided by 9 minus 1 plus 3. That's the third term. Similarly, what will be the nth term or the 10th term over here? It will be 1 divided by 100 minus 1 minus 10 minus 1 divided by 100 minus 1 plus 10. That's it. So we just solve them. We just add it. That's it. So it will be minus 1 minus, I guess it's 1 only. Addition with 1 by 1, or I think that will be 1 only. Minus 1 divided by 4 plus 2 minus 1, I think that's 6 minus 1, that's 5. 1 divided by 5 plus 1 divided by 9 minus 4, that will be 5, minus 1 divided by 12 minus 1, that will be 11. So what will be the 10th term? It will be, I guess, 100 minus 11, that is 99, minus 1 divided by, that's 109. 100 plus 10 minus 1 is 109. So if we add all of that, what will be left? Sorry, and I think there is a half also, which we have not put. Let us just replace the half. So there is a complete half. So you just find the value and divide it by 2. That's it. So you can see that clearly some terms are getting cancelled out. The terms are this one with this 1 by 5 with this 1 by 5. Similarly, this 1 by 99, this 1 by 11, they all will cancel out. Only minus 1 and minus 1 by 109 will be left. So if you try to simplify that, it will be minus 1 by 109 whole divided by 2. So that will be 109 minus 1, which is 110 divided by 109 multiplied by 2. So that is minus 55 divided by 109. That's the answer, and that's the way how you tackle these type of questions. So always remember, let me just give you a small conclusion here. So whenever you have a series type question like this, you always break the function or the term nth or the nth term as a subtraction of two different functions. So what will happen by that? The terms will start cancelling out, just like the telescoping series. We have made a video on that. I'll put that video on the description. You can watch that out. So do follow these concept. If possible, I'll share some more questions in the description. You can try them out. All right then, thanks. We will continue it from here, and stay tuned for more such content. Thank you. Have a good day.